please excuse the lighting and the filming location. This is just an area that I could put this thing down. I've been digging through some old stuff, and this is a slot machine I built. Oh, blimey, when was it? Must have been 1980 or something like that. And it was basically, it was styled on a fruit machine or slot machine with reels, but it's only got 9 lights. So it's got a green, yellow and red light for each of the reels. And the reason they're not lighting at full intensity all the time is because they're actually spinning at high speed. They're going the sequence green, yellow, red very quickly. And then for visual effect, there's a light chasing across. And this thing is played with 2p coins. And if I stick one in, it stops the reels. Oh, a win, that's a good start. Each of the payout pulses drops to 2p coins. So let's keep playing and see how generous it is. Or not generous as the case may be. It goes through phases of generosity. But the diagonals pay out 1 pair of coins, the green and the red pay out 2 pairs of coins, and the yellow pays out 3 pairs of coins. And technically speaking, there's about 3 times 3 times 3. There's about 27 permutations, aren't there? Of the lights, of which 1, 2, 3, bad coin. Of which 1, 2, 3, 4, 5 are winning combinations. Oh, so it's not going to be generous now, is it? I think this machine is at a slight angle, which is why it's not accepting coins so readily. But it works well. And this thing is based on logic chips, CMOS logic chips. The 4000 series CMOS logic chips. And nowadays, if I was designing this, I would use a microcontroller, and the microcontroller would do everything that this had done before, but you could add things like sound effects or more interesting advertising patterns, or you could skew the odds and add other winning combinations. It's quite a smart little machine. It works very well. I think we should take a look inside it and look at my horrific electronics from that era, because it's messy, it's very cluttered. I'm just keep putting money in here. I'm hoping to win again, but I think it's going to eat all my money now. The flaming decal on the front was from Halford. This is a handle for a loudspeaker. The metal box was a panel, and the coin mechanism, I'm not sure where this came from, but the payout mechanism was given to me by one of the technicians at Treasure Island on Jamaica Street in Glasgow. So let's take a look inside it and see what makes it tick. Not pretty at all. So let's take a look in here, and we'll start off by looking up at the logic board. Oh, dearie, dearie me. The logic board has about 14 integrated circuits on it. It's got the 3 oscillators, probably based around a 4093, I'm guessing. Can't really read the chips because I don't want to take that circuit board out, because if I disturb this now, as you can see from the wiring, it's never going to work again. But they're driving 4017s which chased the LEDs. Lots of 4017s. The 4017 was also used for the advertising pattern. The sequencing of the stopping was almost certainly again another 4017 stepping through step 1, 2, 3, and then continuing through like a cam timer in a traditional old electromechanical slot machine. Ultimately, if there was a win, it would fire the payout, the coin mechanism. I'll show you that afterwards. The logic that was used to detect the payout, the transistors, BFY51s, I think, if I remember rightly, for driving the lamps in the front. The relay up at the top was for, is this going to focus on that? It was used with a little counterbalance. It was used as the mechanism to stop you putting in coins if the machine was in play or turned off. Then, the coin assembly. When a coin drops into that chute, it would divert it down. It was made of cardboard. It was the most convenient material at the time. And there's a plastic tube. And if there was enough room in the coin tube, the coin would drop down into the tube and just sit flat at the bottom. Sometimes they sit vertically. It's not great. That happens with all these machines. But once that was full, the coin would actually run over the top of it, and it would come down here and into a little cash box, which looked a bit like this cardboard again, and was stuffed in here. This is the payout mechanism. It's a 240 volt solenoid, and it pulls in like that. And when it pulls in, that little slider lets coins drop down, and then when it goes back again, it pushes them out. So by each time it pecks like this, it fires 2 coins out. It's a bit of circuitry for driving it. This flex looks a bit grubby, and there's a bit of rust inside here as well. The flex comes in rather nicely. It does actually go through a grommet. Is this going to focus? It is earthed. It's earthed onto a little bolt up here, which is nice. There's a little bag down here which contains the circuitry for driving the triac circuitry for driving the solenoid. If I'd known at the time, I was too young, I didn't know at the time, I would have added a snubber network across it, and I'd have added a slight time delay, a little capacitor across the opto-isolator so it didn't false trigger, because when you turn it on at the moment, or off, the glitch as you unplug or plug it in makes the solenoid fire and it pumps out coins. It's very fast the way it does that. It has a transformer down here, which then comes up to the top here, to this little power supply, bridge rectifier and smoothing capacitor. And then there's a little voltage regulator. A voltage regulator, excuse the shitty camera work here. A voltage regulator just stuck in the side to provide, I'm guessing, 12 volts, which was my preferred voltage at the time. And that then powers the logic board. And there's a little switch up here for triggering it instead of the coin mechanism. So it's cluttered. This took quite a while to work out. It took a good bit of drawing of the schematic and then a lot of time soldering all these links in this perf board. But it works. And I think, nowadays, you look at that circuit board with about, how many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, there's 14 chips in it. I'd do that with a PIC 16F627 now, a microcontroller, and get more features. It's surprising how things have changed. But this works really well. It's quite nice. It was quite fun to build, a lot of fun to build. And it works. And even about, 30 years later, is it? It still works. Yeah, impressive. So that's a 9 lite. Maybe I should revisit that sometime.